In today's talk, I'll be covering some of the more advanced tips and techniques in the VS debugger, and specifically I'll be focusing on the new features in Whidbey. I'll be showing you some really cool features, but one thing that I'd like to point out is that I'm using a very recent build of VS, so some of the demos that I'll show you may not work in your PDC builds. So with that, let's get started. Before we get into details of the new Whidbey features, let's take a look at the larger context of this release of Visual Studio. Back in Visual Studio 2002, we had a brand new platform, and we had a number of new technologies such as ASP.NET and web services. And with that, we had one common UI and one common debugger that you could use to debug all types of applications and languages. And if you wanted to, you could even debug across those languages. Between VS 2002 and 2003, we received a lot of customer feedback and focused on the general usability of the debugger. We also looked at some of the larger areas like performance and security. And some of the features that stand out from 2003 include the ability to be able to view collections such as an array list or a hash table more intuitively, as well as we took the first step in bringing back the RAD debugging experience for Visual Basic developers by providing IntelliSense in the immediate window. And that brings us to Visual Studio Whidbey. There are a ton of new features in the debugger today, and I mean a ton. But if I have to summarize what this release of Visual Studio is about, I would say it's all about improving developer productivity. With that, though, we also have support for some new platforms like 64-bit, as well as SQL Server Yukon, which is the next version of SQL Server. I'll go into more detail later on those. Beyond Whidbey, we want to make sure that we continue providing a great debugging experience for developing applications on Avalon, Longhorn, WinFX, and so on. Okay, so now we've seen the debugger in a larger context. Let's look at some of the details right now. I'll start off the presentation by showing you the new debugging tools that you can use for debugging Visual Basic applications, which then leads nicely to the next developer productivity feature, which is all the new features for viewing data in the debugger. As I mentioned before, we also support some new platforms in Visual Studio Whidbey, and that includes 64-bit debugging as well as debugging SQL Server Yukon. And lastly, I'm going to open up the debugger toolbox and give you a glimpse of some of the new features which aren't quite in yet, but will make it by the end of the time we ship Whidbey. So, with that, I'm sure that by now most of you have heard that Edit and Continue is back for Visual Basic. And I'm sure all you Visual Basic developers are super, super excited about that. But we didn't stop there. We wanted to also make sure that you have a great debugging experience when you're handling exceptions and errors in the debugger. We wanted to provide you with as much information as possible when you're dealing with exceptions. And that led us to the feature that we call the Exception Assistant dialog. To show you how these features work, let's look at the brief demo in Visual Basic. What I've got right here is a simple Windows Form application that basically loads some data out of an XML file. So what I'm going to do right now is I'm going to start debugging this application, and let's see how the interaction of the Exception Assistant dialog and Edit and Continue play nicely together to provide a seamless RAD debugging experience. What this will do right now is it'll go ahead and launch the application, and when I hit the load button on the dialog, you'll notice that the application actually crashes. This is what I mean by the new Exception Assistant dialog. you'll notice a number of features about this dialog. First of all, the actual type of the exception is displayed in the title of the dialog. And next, we have the reason of why the actual exception occurred. One of the great features about the exception assistant dialog is that it actually provides troubleshooting tips. From here, you can find out more information about the exception, and for some certain exceptions, we also provide you step-by-step procedures for fixing that exception. You can also view the details of the exception, and I'll show you in a second what that looks like. But from here, what you can do is you simply go ahead and break in the debugger. Once you've done that, you can dismiss this dialog, but as you can see, there's this smart tag which allows you to bring back the dialog anytime that you like. So obviously, the problem here is that we can't find the file called data.xml. To fix this, let's go ahead and actually change this code entirely. So rather than hard coding the path to the file, we'll load the data out of a path that the user specifies. What I'm going to do right now is I'm going to actually declare a open file dialog object. And next what I'm going to do is I actually want to capture the result that I get back from that dialog. So I'm also going to create a type of dialog result. And I'm going to capture the return value from the dialog box that I get back. In this case, I actually want to show the dialog. Once I've done that, I'm going to check the return type. And if it's OK, then I actually want to read in the information. And what we also want to do in this case, we actually want to open up the location of the file specified. So in this case, it'll be open dialog.filename. From here, notice that I haven't stopped debugging at all. I can simply go ahead and continue my debugging session. And what that just did is it's actually executing all the new code that I just typed in. So from here, I'm going to specify the path to the data file. And what you can see right now is it actually loaded the data that I had specified in the file. So it's a great productivity feature where you don't have to stop debugging and restart debugging again. In Visual Studio 2003 or 2002 today, there is no shortage of tools for viewing data in the debugger. Let's see, we have the autos window, the locals window, the this window, the for watch windows, we have the memory windows, and so on. This is great because it means that you can view the state of your application in different ways. Unfortunately, though, when you try and get to the data that you're actually interested in, it sometimes can be a bit of a challenge. To show you what I mean, let's look at another demo. This time, we're using VS 2003 to look at some data in the debugger. What I've got here is a very simple C# application that simply declares a double that calculates the square root of 934. I have a custom type called employee, which has the canonical members such as name, social security number, and so on. I also have some very common used types such as string, XML, HTML, as well as a complex data type, a data set, which is used very commonly from the .NET framework. Let's go ahead and try and debug this application right now and see the available tools in Visual Studio 2003. The first thing that we have available at our disposal is what we call the data tips. You can simply hover your mouse over any variable and you get a value for it. So in this case, when I hover my mouse over the double, over I, which is of type double, I get the return. I can actually see the value. Now, if I do the same thing over the employee type, which is actually a custom type that I wrote, unfortunately, as you can see, what you'll see is the actual name of the type instead, rather than some useful information. The same is true right now. If I look at a really long string, that's kind of unreadable. Same thing happens if I look over a HTML type. Again, that's not very easy to read or understand. Now, let's look at something like a data set, for example. Again, the data set simply displays the name of the type, but let's do a quick watch on it and see what we can see in the data set. Now, I challenge you all to try and find the data in this data set. Let's see if we can find it. I know one of the biggest problems here is that you actually have to have intimate knowledge of the structure of the data set, right? You have to remember a data set is made up of tables, which is basically a list of rows. And then when I drill into that, I'm going to have to find the rows collection, which is somewhere here. Once I've done that, again, I know we have a list of rows, and so on. And by the time you get here, you're thinking, So as you can see here, again, all the data is there, but the challenge is how do you go about finding the information that you're interested in? Now, let's switch forwards and look at, actually before we go there, let me just do a quick recap of the demo that I just showed you. As you saw, data types are great for debugging code right in the editor. If you have simple types such as double, integer, float, and so on, it's great to see the data right there. But if you have a complex data type, unfortunately, all you see is the name of the type itself, which is not very useful. The data windows, such as the locals window, as you saw right there, are great for viewing data in a hierarchical form. But again, when it comes to complex data structures, such as a data set, it's actually quite difficult to find the data that you're interested in. And last but not least, we don't have a proper way in the debugger today to extend how you view data. You cannot customize it so that, for example, if I want to view a hash table in a certain format, I can extend the debugger. Now let's look at debugging the exact same data types in Visual Studio Whidbey. I'm going to do my magic virtual PC right here. Okay. Again, this is the exactly same application as before. And this time, I'm going to walk through the exact same steps, and let's see what the changes are. Again, if I hover my mouse over a scalar value like a double, you'll get the same result. But notice something now. If I hover my mouse over something like the employee object, you can actually extend the object right in place and look at the data members right then and there. You don't have to go anywhere. We found this is a great productivity boost where a lot of people that have seen this now don't actually use any of the other debugger windows right now. It's actually, and the great thing is right from here, you can actually edit the value or you can add it to the watch window as well. So again, it's a great productivity boost. So now let's look at our old data set again. Actually, before we do that, let me bring up the locals window and try and see what the other data types look like in the new VS debugger. One thing that you notice immediately is that next to the value of the really long string, there's just some kind of icon that looks like a magnifying glass. If you drop that down, you can actually now view text as different types. So in this case, I have a very long string, and I want to view it as text, right? I can actually wrap that or unwrap it as well. So again, if you want to debug any type of long strings now, you can do it right in the debugger without having to do copy and paste, which I think just about everyone does. Now let's look at our old HTML file. Again, we have this icon right there, and we want to view it as HTML. And you can actually debug your HTML string live without copying and pasting it into a text file and then view it in IE. Again, all the tasks can actually be done in the debugger right now rather than going somewhere else. The same is true, of course, for the XML that you have. You can view something as XML, and again, you can view it right then and there without having to go anywhere else. But the most exciting thing is actually the data set. This is a prototype right now, but what you actually want to do is view the data itself, right? And in this case, you'll actually see the data, and you can navigate through the different tables and see the data the way that it was meant to be, which is rows and columns. So we think this will be, again, a huge productivity boost for you guys out there. But please excuse the UI right there. This is simply a prototype. But the really exciting thing is that you can customize all of this. I think that's going to be a tremendous, tremendous boost for productivity. And I'll show you how to do that later on. So I showed you all these new cool ways to view data in the debugger. And of course, you want to find out now, how do I do this for my own data types? Well, there are actually several levels of customization in the debugger. First and foremost, the simplest way of customization is go ahead and override the toString method to see a string representation of your data. So in this case, I have the employee type, and if I want to see the first name appended to the last name of the employee, I simply go ahead and override the toString, and the debugger will display that value in the value column. Let's see what that looks like in the debugger. So I have my employee type right here. And what I actually want to do right now, I'll go ahead override the toString method. And what I want to do is I want to return this dot first name, this dot last name. Now, when I do that and I start debugging the next time, what you'll actually see in the value column is, again, I should have, the caveat is this is the latest version basically of VS that I could pick up. So, stuff like that happens. So, damn you demo gods. All right. I'm going to be, do I have, all right. I don't have connectivity right now, otherwise I would have sent in the error report. But you all should always send the error report. Trust me, I always do it. Okay, let's see if we can pull that up again. So, as I was saying, hopefully that saved my changes. Yes, it did. Excellent. All right, crossing figures. Excellent. All right, so if I look at the employee object right now, you'll actually see that the first name and the last name are displayed in the value column rather than the name of the type itself. So that's how you customize the data view in the debugger at the first level. What does the second level of customization look like? Well, there may be times where overriding toString may just not be enough. As I mentioned before, the debugger displays information in a hierarchical view. And there may be times where there's just too much information that you're not interested in. A really good example is if you had a hash table, right? If you look at a hash table, you can actually see all the implementation details. But what you're really interested in is something like the key and value pair, and that's it. And that's exactly what these three attributes allow you to do. I'm going to briefly describe what they do, but I'm only going to demo the debugger display attribute. With the debugger display attribute, you can customize exactly what's displayed and format what's displayed in the value column. Next, we have the debugger browsable attribute that allows you to configure a type to display a certain member or not, or to display the entire type or not. So, for example, if I wasn't interested in viewing let's say, the email address of the employee object, I would simply slap on the debugger browsable attribute on that field and specify that I'd never want to see that type in the debugger. And the most elaborate way of customizing the way data is displayed in the debugger windows is via the debugger type proxy attribute. This is rather complex, but essentially what it allows you to do is that it allows you to substitute a type for your type at debug time. So that, for example, if you have a hash table, you can tell the debugger, this is how I want the hash table to be displayed in the debugger. Now, let's look at how you can go ahead and use the debugger display attribute. I'm going to go back to Visual Studio, and I'm going to do a bit of a magic right here since I'm using the alphabets. Trust me, you don't have to do this when we ship Whidbey, but as I mentioned before, I'm using the most recent version of Visual Studio, so I'm going to have to do a bit of cheating. I'm going to have to just reference a DLL right now that's needed for this demo. Okay. Now, let's go back to our employee class. What we can do here is, rather than displaying the first name and last name, I actually want to display the ID of the employee in the value column of the data windows. So I can simply go ahead and select the debugger display value, and it takes a string as a parameter. I can type in whatever I want in here, but it makes sense that I want to identify the thing that I'm displaying. So I want to say display the ID, and then whatever you enclose in the curly braces is whatever the debugger displays from that type. So in this case, I want to display the ID, so I enclose that within the curly braces. Now, if I go ahead and debug this, hopefully you'll see the ID of the employee rather than the full name. Again, let's look at the employee. As you can see right now, it's displaying the ID rather than the first and last name. It's a great way to customize the way that you want the debugger to display your data. Okay. So we've covered two ways of customization for your data types. But there's still yet another way to customize it, and that's probably one of the most exciting ways, because it means you can totally break away from the hierarchical view of the debugger and display the data any way that you want to. So for data types like, as you saw, dataset, XML, and in image, the hierarchical view just doesn't work. As you saw, you have to drill down several levels to be able to get at the data, and when you get there, you're not even sure whether it's the right data that you want. What we've done in Visual Studio Whidbey is that we've said, okay, we know people have their own custom types, and we know they want to be able to view it the way that they want to. Why not provide them with the mechanism to do that? And that's exactly what we've done. Let's look at another demo of customizing the debugger in yet another way. Let me remove this before I do anything. Oh, excuse me while I'm... Again, since I'm using the most recent version, I'm going to have to do a bit of cheating here and there. But when we ship, this will be all real. Okay, so let's look at the employee object right now. Actually, to make it easier, I'm going to use something like the Quick Watch window so you can see the full view. Again, I'm going to right-click and say Quick Watch. If you look through the employee object, you'll notice that it has a type called photo, which is meant to display the photo of the employee. Again, if I want to debug the photo object, it's not very useful to drill into the debugger windows because, again, if I'm after the data, what I really want is the actual photo, the image of the employee. So let's abandon this and go back and see what we can do there. With the Whidbey debugger, you can actually write a custom class. In this case, I've called it an image viewer that allows you to display the actual image of the employee. Let me just give you a quick view of what that looks like, then I'll go back and show you what the actual mechanism is behind the scenes. So I'm going to copy this DLL. By the way, this will be all, of course, documented when we ship, so you won't have to remember any of this. Oh, don't do that. Okay, let's start debugging this again, and this time look at the photo field again. Again, I'm going to use Quick Watch to look at the type. And this time, you'll notice that there isn't a magnifying glass there. Okay, let's try that again. Okay, demo gods, let's. Okay, let's try that once more. Expand the employee type and look at the photo object. Okay, that didn't quite work. Let me see if I can shut down VS and restart. I'm going to open up the project again and see if this time we'll pick up the changes that are made. You can go away. Again, let's expand the employee object. And this time, you'll see that there's an icon. And look, it's Homer Simpson. So, again, as you can see, you can completely break away from the way that the debugger displays data in a hierarchical view and display the data in the form that you want to, and it's in its own natural form. There are literally billions of possibilities, right? You can write any kind of custom viewer that you want and view data in any way that you want. Question?
Are you going to be able to put that in a tool window that we can dock as well, or is it always just a standalone window?
That's a great question. The question was, are you going to provide a tool window where we can where you guys can actually display the type in there, or is it going to be always a standalone window? For the plans are still to be decided, but most likely for the Whidbey version, we'll probably go with the standalone window, and hopefully in the future versions, we'll look into providing a tool window where you can display your data in there. Okay. Now, for those of you who are really curious about how all that stuff works, here's a very brief architectural overview. What I have on the right-hand side is Visual Studio. That's where the debugger lives. On the left-hand side is the actual application itself. And that includes the image type. What happens when the debugger enters break mode, it actually looks at the image and checks whether it has a viewer associated with it. It does that through a debugger visualize attribute, which I'll show you in a second. If it does have a viewer associated with it, it looks in a special directory. We haven't exactly defined what that directory is to load the image viewer from. It loads a copy of the DLL in the debugger, and it also loads a copy in the actual application itself. The version in the debugger is what actually displays the form that you saw. Or it's very simple. It literally just takes the data out of the image, it stuffs it into a Windows form, and it displays it. In the actual application itself, which has the visualizer object source class, that's where the serialization of the data happens. By default, we provide a binary serializer, but you can extend this type and provide any custom serialization that you want. To make this work, you need to make sure that the image viewer, in this case, implements an interface called iDebug Visualizer. And as I mentioned before, you can customize the marshaller or the serialization, the object that does the serialization, by inheriting from the visualizer source, object source. Let me show you very quickly what the actual code looks like. It's literally about 40 lines of code. It's very, very simple. This is the visualizer for the image object that you saw before. Looks pretty nice, doesn't it? Okay, again, please send in the error report. The solution is actually made up of two separate projects. One's the WinForm control itself. In this case, this is the image viewer. And the other part is the thing that does the serialization. So we're going to look at the image visualizer.cs file. And as I mentioned before, you simply specify the debugger visualizer attribute on the type that you want to visualize. In this case, you're saying the thing that does the serialization is the visualizer object source, and the thing that displays the actual type itself is the image visualizer. If we go down a bit further down, you'll notice that image visualizer simply implements iDebug Visualizer, which has a single member called show. And again, as you can see right here, all we're doing is we're getting the data out of the image, we're stuffing it in a form and displaying the form. So, and if you look, it's around 43 lines of code. So it's very, very simple to write your own custom viewer in Visual Studio Whidbey. In summary, again, there are three levels of customization that you can do. Simply override toString, or use attributes to modify the current data windows, or completely extend the debugger so that you display the data any way that you want to. Again, I encourage you all, it's a great way to improve your productivity. If you have a custom type that you want to view in a special way, I encourage you to go and extend and provide your own custom viewer. But what about all you C++ developers out there? No, I haven't forgotten you guys. If you're debugging STL types and collections today, you've probably found that it's a pretty daunting task. You thought debugging a data set was kind of difficult. Wait till I show you what debugging an STL type looks like. What we've done in Whidbey is that we've provided very intuitive ways to debug the most common STL types and containers, such as a set, vector, string, and so on. In this case, I have an example of an STL map which simply has a key value pair of the weekdays mapped to the numbers associated with those weekdays. Let's look at what this looks like in Visual Studio 2003 first. I'm going to go ahead and change the configuration and set up as the startup project. And I'm going to use Quick Watch again to look at the actual map itself. Now, if I want to see, today in Visual Studio 2003, if I want to see the data in the map itself, let's see what you need to do. No, it's not there. Maybe it's there. So for you C++ developers, it's kind of a daunting task to go and actually find where the data is. Now let's look at the same view in Visual Studio Whidbey. So I'm going to stop debugging and I'm going to go to the Whidbey version of Visual Studio. Load up the previous solution that I had, which was the debugger demo solution. And set up my startup project again. Again, I'm going to start debugging. And this time, let's look at the same map object in Visual Studio Whidbey. As you can see, it's much, much more intuitive to look at the data itself. It's simply a mapping of key value pairs. And again, you don't have to go through all that level of indirection to even see what's in your STL map. So again, we think this will be a great productivity feature for you guys who are writing apps using STL data types.
Is that hard-coded in? Is that hard-coded in for your, just those?
That's a great question. The question was, is that hard-coded in? And the answer is yes for Whidbey. But hopefully going forward, we'll be able to extend that.
What about MFC?
The question was, what about MFC? And the answer is there isn't currently any of the same visualizations that you see for STL types. Okay, as I mentioned at the beginning of this presentation, we also have support for some new platforms. Can I see a show of hands of the number of people who are thinking of or right now writing apps for 64-bit platform? Wow, that's quite a number. That's great to see. Well, the good news is that with Visual Studio Whidbey, you'll be able to debug applications written for 64-bit. Not only that, you can debug 32-bit processors running on WoW64, and you can also debug 64-bit processors running natively on 64-bit processors. Of course, you can do that both locally and remotely, and using both managed and unmanaged code. This is available for both AMD 64 and IA64, so if you're developing for either of those platforms, you'll be able to use the debugger. So how does that work? What I've got right here is my 64-bit machine, which includes the WoW64 subsystem. In summary, what the WoW64 subsystem allows you to do is that it allows you to run 32-bit processes on your 64-bit box. VS itself is actually a 32-bit process, and it runs on WoW64. So if you're trying to debug another 32-bit process running on WoW64, that's not a problem at all, and you can do it without doing any configuration and so on. But what about debugging a 64-bit process? Again, the experience is seamless. You can easily attach to a 64-bit process and debug it that way. This is for local debugging on a 64-bit machine. But what about remote debugging? In this case, what you'll actually see is a 32-bit machine. And the difference is that VS was on the 64-bit machine before, but now it's on the 32-bit machine. Again, to debug a 32-bit process running on WoW64, it's not a problem at all, and it's all seamless. The only thing that you need to do is to make sure that you have the 64-bit remote debugging components installed on the remote machine. Likewise, for a 64-bit process running natively on the 64-bit machine. Again, you don't have to do any special configuration or anything else. It simply works. Another new platform that we're supporting with the Visual Studio Whidbey debugger is SQL Server Yukon. Can I see a show of hands of those people who have heard of Yukon? Very good. All right. Have you seen any sample code written for Yukon? Excellent. All right. So this will be a good demo. One of the things to remember again about the debugging experience for Yukon is that it's seamless. And I'll show you in the demo, you don't have to do anything special. It's the same debugging commands. It's the same types of things that you do to debug your SQL Server data objects. You can set breakpoints anywhere, and we support debugging on Yukon both locally and remotely. You can inspect any data types, including T-SQL types, user-defined types, as well as any other managed objects. So let's see what that looks like on a demo. Of course, we have the great security feature of Windows Server 2003 that locks you out after a few. And if I can remember my password, that would be nice. No. Okay. Let's try again. No. Okay. Yay. Excellent. Okay. That would have been quite a short demo. Okay, I'm going to walk you through very briefly what I've got on the screen right there. The point of this demo is that you can debug seamlessly between your SQL CLR managed objects and your T-SQL database objects. What I've got right here is a SQL Server Yukon stored procedure. It's managed code, and all it does is that it calls the by royalty T-SQL stored procedure, which simply returns the list of author IDs that equal a certain percentage. So in this case, I've specified the percentage as 100. Some of the things that you'll notice is it's decorated using the SQL procedure attribute, and it's a static function. Simply what I'm doing is I'm creating a command for calling the T-SQL stored procedure, setting up the parameters for calling the T-SQL stored procedure, and next I'm simply executing it. So how do I go about debugging this? Again, very simple. Using the gray margin on the left, I'll set a breakpoint, start up the debugger, and the project system does all the work of compiling the DLL and deploying it to the project, and the debugger does the work of attaching the process and start debugging it. Again, I can use the normal debugging commands to step through my code, and in fact, I can even step into the T-SQL stored procedure right here. And from here, I can execute my code, but as you can see right here, it's actually starting to print out the result of the return types, of the return values that were returned by my by royalties stored procedure. So the point of this demo is that, again, there is no special setup or way of debugging your SQL Server Yukon managed data types. You simply debug it like any other types of application. Okay, as I promised you at the end of this presentation, I would go through and give you a glimpse of the new features that are coming online that will hopefully empower you to debug those tricky situations that you couldn't do before. I've bunched these up under what I call the debugger toolbox, starting with symbols management. Just a very quick description. For those of you who are not familiar with debugging information, or what we sometimes call debugging symbols, they're basically files that allow you to debug. They're commonly referred to as PDB files as well, and they have the .pdb extension. A lot of times we would receive requests from customers about their breakpoints not being bound and so forth, and it would eventually lead down to the PDB file not being present. We've provided a number of great features for being able to discover exactly why your symbols aren't being loaded, and being able to see where the debugger looked at for finding your symbols. Next, we have another quite advanced feature. For those of you who are writing C++ applications today, you're probably familiar with this feature. You can set breakpoints on a specific instance of a type. And in Whidbey, this will be also available for managed objects so that you can break on a specific instance. Next, we've done a huge amount of work to improve the remote debugging experience. I think those of you who are doing remote debugging today will be pleasantly surprised by how much easier, robust, and secure the debugging experience for remote will be in Whidbey. Trace points. You're all familiar with what breakpoints are, right? You set a breakpoint and your application breaks at a certain location. The idea behind trace points is that what if you didn't want your application to break there, but you wanted to perform some other action? Let's say you wanted to print out a message or log a message or run a macro. The idea behind trace points is that that's exactly what it allows you to do. For logging applications where you want to log the information rather than break, you simply go ahead and set a trace point on a certain line of code, and you can either write a message or dump out the current context where that trace point is. And this is actually one of my favorite features in Whidbey because it should get rid of a lot of the times where you have to use printf to display the information. Processes window. We have a new window called, and it's a non-modal window for debugging multi-process applications. Using the processes window, you can manipulate your processes, you can detach, you can terminate, and you can attach to further processes. And it makes multi-process debugging a lot easier in Whidbey. Debug in zone. For those of you that have seen the click once demos, and I think there will be a presentation this Thursday, it's a new technology for downloading and running Windows applications from the web. What basically debug in zone allows you to do is that you can test and debug those applications before you deploy it. So the turnaround time for testing, deploying will be greatly reduced by seeing what your application does under certain security contexts. Again, there should be a demo this Thursday about how that works. Console window. If you're writing a console application today, you probably see and interact with your application using the DOS box, right? Well, in Whidbey, we're actually providing a window within Visual Studio itself that takes input as well as displays output from your application. And lastly, per thread breakpoints. Currently, in Visual Studio, when you set a breakpoint, it applies to all threads running in your application. But in Whidbey, you'll be able to say, break on this specific thread rather than on all threads. Again, this will be a nifty feature for those tricky debugging situations. With that, let me show you a quick demo about the new symbol management features that we have in Whidbey. Okay, this is the old application that I showed you before, the STL maps one. So what I'm going to do right now is I'm going to start debugging. To start looking at how the debugger and where the debugger looked at for your PDB information, you start off from the modules window. And the modules window, for those of you who haven't used modules window, allows you to see the current assemblies that are loaded into the process as well as which ones have PDBs loaded for them. You can right-click. Oops, excuse me, I'm actually using the Everett version of. Let me try that again. I've just switched back to using the Whidbey version of Visual Studio. And let's see. And it's pretty much hung. Okay, let's try it again. Okay, so I'm going to load up the STL solution again. and to try and see the new features that we have for symbols management in the debugger. I'm going to start the debugging session. And okay, so this is not playing very nice. Let's try another version right here. Okay, let's bring up the modules window again and have a look at what we have. Okay, so as I mentioned before, using the modules window, you can actually see where the debugger looked for your PDV information. We have this thing, a command called symbol load info that basically tells you all the places that the debugger looked for your debugging information. So if there isn't a specific place where the debugger was meant to look at, but it didn't, you can just find out where that was. And also from here, you can access the symbol settings pane, which allows you to specify the location of a symbol server. And in brief, a symbol server is a store that allows the debugger to automatically find the symbols for your application. It's a great, again, productivity feature if you have a big enterprise where you have nightly builds and you want to store all your symbols to a central location. You can simply go ahead and add as many symbol servers as you want. You can even use this, if you're debugging native applications, to specify the Microsoft public symbol server, which is at msdl.microsoft.com, and be able to look at the call stack for Windows itself. Okay, I'm going to switch back. And that just about wraps up our presentation today. So in summary, what you saw was we now have a bunch of new tools and technologies for debugging your data. And we've also provided a number of tools for debugging your Visual Basic applications, including edit and continue, as well as the exceptions assistant dialog. The Whidbey debugger also supports new platforms such as SQL Server Yukon and 64-bit. And lastly, when Whidbey ships, we'll have a ton of new power tools for debugging your applications. With that, I'd like to thank you all for attending, and happy debugging.